Welcome back. Today we're going to look at pointers and returning multiple values from a function. So how do we use pointers and how do they store information in memory? Well, a pointer is a data type that holds a hexadecimal address. So in this case, 0066FDF4 is the memory address. By the way, the reason why these zeros are small is just because of the font. These are just regular zeros. And 0x is just the way that C++ represents the fact that it's about to represent a number as a hexadecimal. So the real number for the memory address is 0066FDF4 in this case. And a pointer is basically a variable, a place in memory that we can store an address into. And when the pointer variable contains another variable's address, it's said that the pointer points to that variable. Pointers don't have their own keyword, but you have specific declaration statements to say that a variable is going to store a pointer. And we have an operator, the asterisk operator, is used to make that declaration. So here's the format. You have your data type, and then you have an asterisk, and then your identifier. And that asterisk, basically the way I want you to read that asterisk is this variable name is a pointer to that data type. So we could say, so this operator means this variable name is a pointer to that data type. That's the way you want to kind of think about this. So there are several naming conventions when we declare pointers that are often used. Sometimes an underscore and PTR is added to the identifier. I realize you can put an underscore as part of your variable name, and that just makes it clear that this is a pointer. Another possibility is putting a lowercase p before your variable name, and the p would be lowercase because variable name should start with lowercase, but then your variable name would start with a capital. It'd be camel cased essentially. And another is to use a p with an underscore. I kind of like this format here where you just put a p because it's one less character than using an underscore. And so let's say, how does this work? Well, let's say we declare a variable a and we assign a value 75 into a. So remember, what we're doing here is we're saying reserve 4 bytes because an integer takes 4 bytes somewhere in memory on the stack and call it a. And then the next part of this says put the number 75 in the location pointed to by a. So that's there's a lot going on with just a declaration statement. Next, we're going to declare an integer. Now, don't think of this as an integer. This is because of this asterisk, this is a pointer to an integer. So a underscore PTR is a pointer to an integer. Next, what we're going to do is we're going to declare a variable b, which is a double, which again takes 4 bytes of memory, and we're going to store 82 in that 4 bytes of memory we were referring to as b. Next, we're going to declare a variable which is going to be a pointer to a double called b pointer. So we have a pointer and b pointer. A pointer is a pointer to an int. B pointer is pointer to a double. And so we could keep track of what these pointers are pointing to. Now, right now, even though they both have the same identifier letters in here, realize that b pointer is not pointing to b yet, and a pointer is not pointing to a yet. We've just all we've done at this stage is declared a place in memory to store an address that points to an int, but it hasn't been assigned yet. And so the way so here we have, our int a, our double b, we have our a pointer and our b pointer, and in order to set the addresses, and we use our address operator. So we can see here we're saying set the address of a into a pointer. Well, where's a pointer? Well, we have a pointer here, and what's the address of a? This is not assigning a, which has a value of 75. This is not setting the value of a into a pointer. It's setting the address of a. And we can see the address of a is 66FDF4. and that's what actually ends up as the value of a pointer. So the value of a pointer is the address of a. This next statement, set b pointer equal to the address of b, we're saying take the address of b, which is not 82, it's 66FDEC, and assign it as the value of b pointer. So b pointer has 66FDEC, which is the address of b in it. So let's take a look at this. Here we're declaring a pointer called ptrNum, and in its case, it's a pointer to a double. You can put the asterisk either next to your variable or next to your type. I kind of like to put it next to the type because it makes more sense to me to think of this variable as a pointer to a double, and with the asterisk next to the type, it says this is not a double, this is a pointer to a double. So read asterisk as a pointer to. And so here we have ptrNum, and let's say we have a variable already declared in memory called number, which is at 66FDF4. And so when we declare ptrNum as a pointer to a double, just like any variable, it gets a place in memory. And then if we say ptrNum is equal to the address of number 1, hit pause and try to think what is going to go into ptrNum. Is it going to be the 6 or 66FDF4? Pause, think about the answer, and then hit continue. In point of fact, it's the address which is going to go into 66FDF0. So 66FDF4, which is the address on stack, is what ends up getting stored in this pointer. So how do we get the value that pointer is pointing to? If we do this, and we were to just say, output ptrNum, well, are we going to get 6 or are we going to get something else? So think about the answer. And the way to do this is look at ptrNum and see what the value is. That's the value. And realize that cout just takes whatever the value is that this is and displays it. So think about what you think you're going to see on the screen and then hit continue. And yes, so if we just cout ptrNum, what we would get is 660FDF4. And often, that's not going to be particularly interesting to any user. They'll say, what's that? But so normally what we really want is we don't want the address, the value of our pointers. We want the thing that the pointer is pointing to. And we call that dereferencing. So how do we dereference this pointer? Well, the way we use that is, again, we use our friendly operator, the asterisk. And what the asterisk says is it's not going to provide the contents of ptrNum, the value of ptrNum. What the asterisk is the value located at. So when you use the asterisk in a declaration, you would use the nomenclature, the asterisk is a pointer to. But for when you're using it in a statement, I want you to think of the asterisk as meaning the value located at. So in this context, asterisk means the value located at ptrNum. And we can see that ptrNum has the address 66FDF4. Well, what's the value located at 66FDF4? Well, that's this value 6 that's stored at 66FDF4. So when we say give me the value of the item located at ptrNum, that's going to be 6. So that's how we get the value located at a pointer. So if you have a pointer, you put an asterisk in front of it, and it won't return the memory address. It'll return whatever's at the memory address in that pointer. So let's look at a sample program. So here we have a pointer, and we have a pointer and b pointer being declared. This is basically the program in the slides. And we have, and this is where the addresses of A and B are being stored in A pointer and B pointer. And so this is not putting A, this is not going to put 75 in A pointer. This is going to put the address of A into A pointer. And then here we're going to display A and its address, and then we're going to display B and its address. And then we're going to display A pointer. What's an A pointer? and its address, and then B pointer and its address. And let's take a look at this. So we have A, which has the value 75, and B, which has the value 82. And we can see that the address of A is 6FFD9C. Now that's when I ran it this time. Let me see what happens when I run it a second time. Notice that each time I run the program, the addresses are different. And that's because the operating system is going to allocate, each time you run it, it's going to grab different parts of the stack to assign the address. But what we can see is that here, when we declared the variables A and B, and put 75 and 82 in them, this 75 in the second instance that ran was put in CFFA08. In the first time it ran, it was put in 6FFD9C. Notice that B is assigned precisely 4 bytes off of that. So if we go, or actually, let's see. Yeah, so 8, 8, 16. So 16 bytes off of it in both cases. And then we can see, okay, well, what's the value? So this first part here where we're showing the pointers is going to show the value in A pointers. So A pointer got CFFA08. So what was placed into A pointer with this statement up here? Well, the address of A is CFFA08, and that's what was placed in A pointer. So when we do this assignment operation here, we're putting the address of A. That, in fact, is what was put into A pointer. Same thing with B. When we did this assignment here, we see that CFF9F8 is the address of B. That got placed in the B pointer, and when we displayed it down here, that's, in fact, we can see, confirm that B pointer got the address of B. Now over here, they're showing the address of A pointer and B pointer, and you notice that A pointer and B pointer are placed a number of bytes off of B. They're also in the stack, but their value is the address of A and B, even though they have, and then they also have their own addresses as well. So we can see that yes, A and B are variables just like any other variable, except it's just that what's stored in them are addresses as opposed to numbers. So why would we want to do this? Why go to all this trouble? Well, what if we wanted to return more than one value from a function? And so how many values does a function normally return? Think of the answer and hit continue. And the answer is 1. Functions normally only return one value. And so here we have a function called math, and we bring in two doubles called num1 and num2. It adds them together and returns the value. And then if you're going to use this in main, it would look something like this. We would declare maybe two other variables, number 1 and number 2, set them to 4 and 6, and have a variable to catch the results. And so we call the function here math and pass in number 1 and number 2. The values 4 and 6 are copied over to num1 and num2. The addition is done, and it returns the return value, which 4 plus 6 should be 10, would go into summation, and then we would report its results. So kind of a typical function. And so, our math function returns one value. We've added them together, but this is one value. And so try to think about what the output of this program is, hit pause, and then when you've got it, hit continue. And we can see that, yeah, the summation is 10. The two values were added together and we get 10. So, simple function. Now let's say we wanted to return two values. The question could be, well, we can't only do one return from a math, but what if we made the math void and instead we had we just passed in two empty variables, summation and subtraction in this case, and then we just assign the values in sum and subtraction, and then we would return our multiple values through the parameters. Would summation and subtraction be modified when we create sum and sub in the function? If we change a parameter, does it change the original argument that's passed in? And so take a look at this and try to predict what the output would be. Does number 1 and number 2 with 4 and 6 come into here? Do they get added together and the summation gets added to sum, and the sum get copied back into summation? And then does num1 minus num2 get put into sub, and does sub get copied back to subtraction so that when you display these, you actually get the results? Think of the answer and hit continue. Well, no, it doesn't. In fact, you can't. Changing a parameter in a function does not change the original argument that was passed in. And this kind of makes sense. What if we passed in a literal number like a 2 or 7 or something? Well, you can't change a literal value. So it makes sense that that just changing a parameter does not automatically change the arguments that are passed in on the function call. And so let's see how this works. So here we have our declaration statements. We declare all these variables, and we initialize them to some values. You wouldn't necessarily need to initialize summation or subtraction, but sometimes people will initialize them. And then we call our function. And in our function, it declares the memory space for the parameters. So realize, the arguments are not the same as the parameters. When we do our function call, we pass in summation, subtraction, number, and number 1. And so we can see that in memory, what ends up happening is you have num1 gets passed in, num2 gets passed in, num3, the summation and subtraction get passed in, and their values get we say they're passed by value. So what's happening is we are copying the value in number 1 into the parameter num1. We're copying the argument variable 6 into num2, and so the value 6 gets copied over. The value of summation gets copied into the parameter sum. The value of the parameter subtraction gets copied over into the parameter 0. So the arguments that you're passing in the calling statement are the values of those variables are copied into the parameter variables in the function. So these are copies. And you can tell they're copies because they have different memory addresses. Now, in your function, when you do your additions and subtractions here, num1 and num2 go into sum. Well, where's sum? It's not here. It's down here inside of the function. So when you add those two together, we can see that num1 plus num2 is 10, and that gets assigned into this parameter sum. When we do the subtraction, it goes into sub, which is at 66FDD8. Notice that summation, which is at 66FDEC, has not been changed, and subtraction back in main, which is at 66FDE8, has not been changed. So when you do the output, we can see the original values that were in main are used when this statement in main is executed, and so it can't see, the main function can't see what was in the function, so it doesn't change the original values. So now the question is can we fix that problem with pointers? Can we fix the fact that these numbers, which are in main, are not changed by the function? The answer is, of course, yes. So we're going to change the way we declare our function. Notice that sum and sub now are declared not as doubles, but as pointers to doubles. So sum is a pointer to a double, sub is a pointer to a double. And when we call the function, we're not passing in the values of summation and subtraction. We are passing in the address of summation and subtraction. So now sum and sub are pointers, and they're getting the address of. So when you're using pointers, you have asterisks in the parameter list, and then you have ampersands in the function call. So you're going to want to remember that pattern. And then also in the function, when we use the value, notice that we are not replacing the results of num1 plus num2 in the variable sum. Instead, we're placing it in the value referenced, or the value pointed to by sum. So we have that asterisk that dereferences the variable. And so this is a pointer to a double. And we are storing num1 and 2 as the value at whatever sum is pointed to, which is going to be summation. Because sum will have the address of summation. When we dereference it, it will actually put it in summation. So will this return sub and sub to main? And what is the output? So think about the answer. Take a look at the code. And the answer is 10 and minus 2. So yes, in this case, we were able, if you write your code this way and you use pointers for your variables, you are able to pass values back through your parameters and therefore have multiple results back through a function. So let's take a look at this step by step. Here we're declaring our variables. They each get their place in memory in main. So this is in main's variable space. And then in our function has its own variable space. But note that sum and sub are now pointers. So now when we do the function call, notice the difference. For num1 and num2, those parameters, they get the values. The values are copied over. And so we say if you have a regular parameter, it's passed by value. The value is copied into the parameter. If you have a pointer, the value is passed by reference. And we see that what we're passing in is not the value at subtraction, but is the address of. Remember, the ampersand is address of. We're passing the address of subtraction, which is 66FDE8. And 66FDE8 is what's being placed in this parameter. Same thing with summation. 66FDEC is what's placed in this parameter. So it's the address, not the actual values. Now, when we do the summation and subtraction, we can see that num1 plus num2 are added together, which is 6 and 4. And they're not placed in sum, they're placed at the value at the location pointed to by sum. So they're placed at 66FDEC. So what's 66FDEC? 66FDEC is this variable summation declared in main. So now it's doing what we want to do. We don't want to put it here in the function, we want to put it in main so that main can access it. So when we add 6 and 4, 10 goes into summation. Similarly, when we do the next step here, num1 and is subtract from num2, so num1 is 4, num2 is 6. 4 minus 6 is minus 2. That doesn't get placed at sub, that gets placed at the location pointed to by sub. And the location pointed to by sub is 66FD8. And so the minus 2 goes here. And now that means that it's changed the values declared in main. When you then display summation or subtraction, you get the values that were calculated in the function but placed in a variable that was accessible by main. Let's take a look at another program. So here we have a program where we have two functions being declared, ask for info and write info. And in ask for info, well, first of all, we have our declaration of some variables. And notice that here, what we're passing to ask for info is the address of name, the address of age, and the address of pets. So it's the addresses which are going into these pointers and not the actual values. And so we're passing a reference to the values, or we're passing in pointers to the values that were declared in main. And then here we're going to write info, and we're passing in name, age, and numpets. And here we have just a regular function call. But if we didn't do this with pointers, we wouldn't be able to get back three values. And so here we have the ask for info, which takes a pointer to age, and numpets. It asks user for input. And notice when we see in, we're not placing it in the actual parameter for pname. We're placing it in the location that pname is pointing to, which will be, in this case, the address of name, which is this variable name. And notice the use of the naming convention. Since we're using pointers, we put a P in front of the variable, or the argument name, the parameter name. And we get age, number of pets. Notice we always use cn.ignore after last cn in a function. And then write info will get all three values and just display them in a nicely formatted statement. So let's run this one time just without debug. And let's see, I own one pet. And we can see, yes, the functions actually work. But let's see what this looks like when we actually run this. So I'm going to put a stop point here, and let's see if what we can figure out. So we're going to run this in debug mode. And we're sitting here declaring our variable name. So it might be useful to see yes. So here we have name that's been declared. I'm going to hit F10. And we have our variables, age, name, and numpets. Actually, we'll look at locals. There's age, name, and number of pets. And we're sitting in front of this function call. And you notice if I just look at name, it shows me that, we have name and it's got no value. We've got age. It's the usual, largest negative number default. But if I highlight the whole parameter or argument here with the ampersand sign, we can see that what's really being passed in is this address, F9BFBE8. And what's being passed in for age is is the address. And in this case, in curly braces, it shows you what value it is. But the real thing that's being passed in here is this address, in this case, F9FBD0. And that's what's being shown in the locals, actually. So I'm going to step into this function with F11. And now we're at this function, and the question is what came into pname. Notice that pname got an address. Page got an address. Numpets got an address. And if I highlight at pname shows its value, but pname shows the address. So I'm going to hit F10 a few times. I'm going to do a get line. Did pname get Rob? In actuality, no. Pname is this address. What actually happened is the address at FBFN9, it has the value Rob. So we dereferenced this variable. It's actually putting it back here in main at this location. Now we can't see it yet because name is not back in scope yet, but we'll go through and step through the rest of these and see the same thing happening. I get an age. And then we can see that number went in. Get number of pets. And that number went in there into that memory location. FD F9 FBD0. Let's remember that F9 FBD0. We're going to hit F10. We'll come out of the function, and we can see numpets has a value 1, age has the 150, name has Rob. And so we can see we did in fact change the variables in main through this function call. And then if you continue, you would display the results. So what I want you to get from this is, on one, understand what each of these, what this nomenclature means. When we have an asterisk, when we declare a variable, we're declaring a pointer to, not an actual variable, and always put a P or something in front of those variables so that you know that it's a pointer and not the actual value. That way, when you use it in a statement, you'll remember to put an asterisk in front of it to dereference the address. Now look at the pattern. So one of the complex things with pointers that beginners have a difficulty is where do they put the asterisks and where do they put the ampersands? Because you're constantly, and invariably you'll put them all over the place and try every combination as you're programming to try to get it to work. But take a look at this pattern. Notice that the asterisks are going in the variable declaration and the function prototype. That's where the asterisks go. The ampersands, when you're using pointers, go in the calling function, which is typically main. So if you remember that, when you call the function, use ampersands. When you're declaring the function, use asterisks. It'll kind of keep you out of trouble. So why are other reasons we might use pointers? So one use of pointers is, as we showed, to return multiple values from a function through the parameters. But before computers were as fast as they are today, it was important to be extremely efficient when you're writing your program. And so pointers can be extremely useful when you're passing large amounts of data back and forth between functions, because you're not actually passing the data. Imagine if you're passing an image which had a 640 by 480 image, color image. Each pixel is represented by 4 bytes of information in order to have color value, maybe an alpha channel. And so that's it can be around 900K bytes of information. If you had to pass that back and forth between functions every time you passed it and copied it over, it would be expensive in processing power. But a memory address is very small. It's just a few bytes of information. And so it's much easier to leave the image in memory in one place and just pass the addresses around. So, imagine you had this image program and you wanted a function that calculates stats. Notice here we have this place in memory. There's 900K bytes, but we're not really passing 900K bytes. We're passing addresses to an image. And so we're only passing a few bytes. And then we use dereferences of the pointers in order to do the calculations and dig through that image file. So let's let's consider the following question. Pause your program. Pause your video and then write the code to declare a string variable called placeName. Pause and write down the answer and then hit continue. Okay, so the code declares a string variable called placeName. So it would just be string and placeName. Pretty simple. Write the code to see out the address of the string variable placeName. So pause, write down the answer, and hit continue. So the code to see out the address of the string would then be something like that. Maybe we'll add in an end line. So there's a carriage return. It'd be something like that. And, presumably there's something here that does this assignment. But that's how you would see out the string variable. Now write the code to declare a pointer variable called ptrPlaceName that initializes it to the address of the string placeName. Pause, write the answer down, and hit continue. So in this case, what we would do is we would say we need to declare ptrPlaceName. So it's not like this, because that would be a string. What we want is we want an asterisk. And the asterisk could be placed on either side here, but I usually like it there. And so ptrPlaceName is a pointer to, that's how I read the asterisk, to a string. Now let's write the function prototype for a function called showPlaceName that returns nothing and takes one parameter that is a pointer to a string. Pause, write down the answer, and hit continue. So we have all this declared, and so as not to confuse things, I'm just going to put it like this. So we're going to make a function called showPlaceName, and it's going to return void and takes one parameter that is a pointer to the string. So we are going to then again use the asterisk to say this is a pointer to a string. Something like that. So that is the function prototype for showPlaceName. It takes a pointer to a string and returns void. And now let's write the code that calls the function showPlaceName and passes in a pointer to the variable called placeName. So pause, write down the answer, and hit continue. So if we have this function prototype here, in order to call it, what we would do is we would use the name, showPlaceName, and then we need to pass in a pointer to the variable. And actually, what we're going to pass in is the address. So we say the address of placeName. So showPlaceName takes the address of a string, and to get the address of the string placeName, we use the ampersand operator. So we're passing in the address of placeName to showPlaceName so that it can do its work. So at this point, please complete the pointer demo. And we went over pointers and how to return multiple values for functions today. Thank you very much.